Oh, so let's talk about average rate of change. So I'm sure you remember what slope is talking about. So when we talk about slope, we're talking a lot of times before this class in algebra class, you would talk about slope in regards to a linear function. But we can talk about slope with any type of function, so even in curved functions. So we have an example here. Take a car trip, record the distance that you travel every few minutes. The distance s that you have traveled is a function of the time. And so you can see from this graph, this is not a linear function. So this is curved. And so it's going to have different rates of change depending on where you are. So for instance, if we go from this point to this point, so that's pretty straight actually. Um, so that we could say this ordered pair would be 150, and this ordered pair is 2, and let's say 75. So it's about halfway between 50 and 100. So from t equals 1 to t equals 2, we could do it from 0 to 1 also if you wanted. What's the average rate of change? So we'll just say average rate of change. Now, if you remember slope formula from linear functions, the rise over run, so change in y over change in x. This is the same thing. So we're basically seeing how much is y changed over this period of x that we're looking at, or t in this case. So we have the difference in the y values, 75 minus 50, and the difference in the x values, s and t in this case, but we can say y and x, and we get 25. So the average rate of change, or the slope of the line that's connecting these 2 points, and it's pretty straight, we'll kind of assume that it's straight, is 25. Now, what about from t equals 2 to t equals 3? Let's do the same thing. So we already know that one's 275. This one, what do we say? We'll just say 125. So 3 and 125 for that one. So average rate of change between 2 and 3 would be 125 minus 75 over 3 minus 2. And we get 50 over 1, or 50. All right, so average rate of change, and obviously if we continue this line from 1 to 2 and we go up to 3, we're not going to end up on the same, we're not ending up in the same place. So the average rate of change is increasing here, which means you're going faster, of course. And so then we could do the same thing again. I won't work out the calculation, but 4, and then we could say 200, and you can find the average rate of change between 3 and 4. You could also find, it doesn't have to be incrementally like this between each successive point, because obviously time is continuous, so we could pick even 1.5 if we knew if we could find the value of that function there. Or you could do 1 to 3, or you could do 1 to 4. So if we did from t equals 1 to t equals 4, then let's say, we'll just say 4 and 200, and we actually have that, so the difference would be 150. So the average rate of change would be 150, 200 minus 50 over 4 minus 1, which is 3. And so that gives us 50. So you can see, you can find the average rate of change over any point, or any 2 points, I should say, on a graph. And if it's a curved graph like this, then finding the average rate of change over different intervals is going to be different. If it's a linear function where it's just a straight line, then it's always going to be the same. So linear functions always have a constant rate of change. They have a constant slope. So remember, y equals mx plus b. M is the slope, and that is fixed for any particular function when it's linear. But when it's curved like this, the slope is changing. So here it's going up quickly, slows down a little bit, and then it starts going up more quickly. So the slope would be higher here. It would get lower. It'd still be positive, but it'd get a little bit lower here, and then get a little bit higher as we come up. All right, so that's called average rate of change. And so we have the formula for average rate of change is basically the formula for slope. In fact, it is the formula for slope. So average rate of change of the function y equals f of x between x equals a and x equals b is, and we have the change in y over change in x, which if you remember from algebra 1, algebra 2, that is the formula for slope. And f of b, that'd be your y2, f of a would be your y1, and then b and a would be your x2 and your x1. So the average rate of change is a slope of the secant line. So if you're looking at any 2 points along a curve, the straight line is not going to follow the curve, but you can just pick any 2 arbitrary points, and you can find out how much has it changed over that period. And so that's all the average rate of change is doing. We've talked about net change before. The net change is just that part there, numerator, f of b minus f of a. That is called the net change, which we had talked about before. And then if you divide that and you want to find how much did it change per unit of x as x changed, that would give us the average rate of change. All right, so for the function, f of x equals x minus 3 squared, and we have the graph pictured here. Find the net change and the average rate of change between the following points. So we have between x1 and x equals 1 and x equals 3. And so that would be here. So we can see this one is a decreasing or a negative rate of change. This one is a positive rate of change. So for A, average rate of change would be f of 3 minus f of 1 over 3 minus 1. F of 3, we plug in 3, we get 0. F of 1, plug in 1, we get 1 minus 3 would be negative 2 squared, that'd be 4. And then that's over 2, so the average rate of change is negative 2. And then we can do the same thing for the points between, or the average rate of change between 7 and 4. So we can have f of 7 minus f of 4 over 7 minus 4. So f of 7, we'd have 7 minus 3, which is 4. 4 squared is 16. And then plug in 4, and we would get 1. And then that's over 3. So that'd be 15 over 3, which is positive 5. And you can see visually, obviously we said that's negative. And we could also talk about this one is, you can tell this one is steeper, just looking at steepness and not positive or negative, but we can see this one is steeper. So it's going to have a higher rate of change than this one. But that's the basic idea. Average rate of change is just really talking about a slope, and we don't really talk about slope when we're talking about curves, because the slope is always changing. So we talk about the average rate of change. So that's it for this section. Pretty short and concise. So if you have any questions, feel free to email me.